Alright guys, welcome to lesson 11.6. Today we're going to solve some more trig equations, and this time our solving process will include some factoring. So let's go ahead and take a look at some steps of how we're going to do that. So the first thing we're going to do is we're going to move all the terms to one side, and in the process make sure we combine all the like terms together. Anytime you want to solve an equation by factoring, you have to have the equation equal to 0. So we're going to move everything onto one side so that the equation equals 0. The next step, I'm calling it an optional step, but I'll always be doing it, is I'm going to replace an expression like cosine with a single letter. I'm just going to call it C, for instance. And that way it'll end up looking more like just a normal polynomial, and then we'll be able to factor it. The only two factoring methods we're going to look at today are GCF and box method. After we've done with the factoring, I'm going to go ahead and return by replacing the letter with the actual trig function itself. And then after that, we'll be able to solve it like we have been by setting each piece equal to 0. Okay, so that's our steps for the day. Let's go ahead and jump in and try a couple problems. All right, let's begin here. So here is example 1. So the first thing I want to do is move everything to one side so that it equals 0. So I'm going to add this 1 over here to the other side. Now you can't really combine the 1 with anything. So I'm just putting it over there. So it looks like that. Now that looks like a horrific mess. And so instead of having cotangent be there, I'm just going to replace it with a letter. You can replace it with whatever letter you want to. I guess I'll just call it x. So I'm going to replace the cotangent with x. So I have 2x plus x squared plus 1 equals 0. That way it looks a lot less crazy looking, okay? Now, to solve this, I'm going to rearrange the terms a little bit too. We do like to have our squared terms in the front. And so there's our first couple steps. So step 1 is to move everything over to one side so it equals 0. Step 2 is to replace the trig function with a letter of some kind. Step 3 is going to be to factor this. Now, when you have a trinomial like that, that's when you're going to be using the box method to factor it. This is a little bit of review. We haven't seen this in a while. So the first term goes up here in the top left-hand box. The 1 goes in the bottom right-hand box. And our goal is to find two numbers that multiply together to make x squared, which would be x and x, and two numbers that multiply together to make 1, which is 1 and 1. And then we complete our box. And we know that we've done this right so long as these two numbers here combine to make the middle, which they do. 1x plus 1x makes 2x. So we've got our answer, and therefore we've correctly factored this as x plus 1 times x plus 1 equals 0. Okay? Now at this point, we're done with step 3. So step 1 is to move everything over to one side so it equals 0 and combine your like terms as you go. Step 2 is to replace the trig function with a letter. That just makes it look a lot less intimidating and more friendly looking. Step 3 is to go ahead and factor it. In this case, we use the box method. And then step 4 is to replace this letter here with what it represented. Remember, the x was actually cotangent. So I'm going to rewrite this now. This is cotangent of theta plus 1. Like that. And then what you do is you set both of these equal to 0 and solve. So cotangent of theta plus 1 equals 0. And then cotangent of theta plus 1 equals 0. Now, since these equations are identical, we don't need to solve it twice, obviously, right? But you will come across various problems where they're not identical, so you do need to solve both of them. Okay, so let's go ahead and continue now. And this is where all the new stuff is gone at this point. From here on out, it's stuff that we've already done in this particular unit. So that was the new stuff. Let's go ahead and solve it now. If I have cotangent of theta plus 1 equals 0, how would I solve that? The first step would be to minus the 1 on both sides. The next step would be to take the reciprocal on both sides. And then, the reciprocal of cotangent is tangent, and the reciprocal of -1 is -1. Now we're going to look for where does tangent of theta equal -1. That happens over here, and that is at 135 degrees. And the other one is over here at 315 degrees. And that's it. That would be our answer, because we're only looking for answers between 0 and 360, so we don't have to do the whole general solution thing and find other answers and stuff like that. That's good enough. So we've got our two answers. It's 135 degrees and 315 degrees. All right, let's go ahead and have you guys try one of these. Go ahead and pause the video and give this one a try. When you unpause it, you will see all the steps worked out. All right, guys, so step 1 is to subtract 2 on both sides. Step 2 is to replace the tangent with a letter, so I just chose x. Step 3 is to factor, that's what this would be here. Step 4 is to replace the x with the tangent again. And then step 5 is to solve by setting each of these equal to 0 and solving. And even though they don't look the same at first, actually it turns out they both end up just being tangent of theta equals 1. So once again, we could ignore one of them because they're the same answers. So where tangent of theta equals 1 is at 45 and 225 degrees. All right, let's go ahead and take a look at another example. So this is example 2. Okay, so what we want to do is we want to get everything moved over to one side like usual. So we have, I'm going to add the secant. I think that'll just be easier. So that's gone. I have 0 equals -1 secant of theta minus the square root of 3 secant theta cotangent theta. All right, and at this point we're going to replace these things with letters. So I'm going to replace the secant with x, and I'm going to replace the cotangent with y, because those are different functions. So I'm going to replace them with different letters. You don't want to make them the same letter, they are different. And then from there we're going to factor. Now how would I factor this? It's not the box method. You'll notice that this term and this term have something in common. They both have a x involved. So what we're going to do is we're going to take the x out. So this is a GCF type of problem. There's that. Okay. So steps are pretty much the same, right? Move everything to one side so it equals 0. Replace the trig functions with letters, and then factor. On this one, the factoring is different, though. It's a GCF instead of a box method problem. All right. And so now we're at that point where we're going to replace the letters with the trig functions. So the x, we said, was secant of theta, and the y was the cotangent of theta. Okay, and then we set each one of these equal to 0 and solve. So we've got these two equations to solve for, so let's go for it. Secant of theta equals 0. Well, secant of theta equals 0. What I would do is I'd take the reciprocal on both sides. So cosine of theta is the reciprocal of secant theta. And 0 has no reciprocal to it, so that would be undefined. And cosine is never undefined. There's no places where cosine is undefined. So this one actually doesn't give us any answers. Okay, let's go ahead and take a look at the next one here. I'm going to add 1 on both sides first. I'm going to divide both sides by negative radical 3. And then we're going to do the reciprocal on both sides. I am running out of room here, so I'm going to make some more room for myself. But nothing new is happening at this point. We've already passed all the new stuff, which is the factoring and stuff. So let's see. So if I take the reciprocal of cotangent, I get tangent. If I take the reciprocal of this, I get negative radical 3. If I look at my tangent unit circle, tangent is equal to negative radical 3 here and here. And so those two answers in degrees would be 120 degrees and 300 degrees. And so those are two answers. So this piece this is an interesting thing that happened over here though. Secant of theta can't equal 0 because when you take the reciprocal, there's no reciprocal of 0, which means it's undefined. And cosine is never undefined, so there's no values of theta that would make that happen. So there's no solution for that one. That's kind of a strange thing that'll pop up once in a while. But so let's go ahead and have you guys try one like that. Go ahead and pause the video here and give this one a try. See what you guys get. So for this problem, the first step would have been to subtract the 3 sine theta on both sides, which just basically cancels these out and leaves you with 0 equals the rest of it. The next step is to replace the trig functions, cosecant theta and sine theta, with letters. So cosecant, I'm just going to call it x, and sine, I'm just going to call it y. Next step is to factor out what they have in common. They both have an x in common, so I take an x out, which leaves me with negative radical 2y here, and if I take x out of here, I'm left with 1. So there's that. And then we're going to replace the letters with the trig functions that they represent. And there's that. And then our last step is to go ahead and set each of the factors equal to 0 and solve. And when you do that, you get no solution for the cosecant of theta equals 0, and for this piece over here, you end up with 45 and 135. The process is to subtract 1 on both sides first, then divide by the square root of the negative square root of 2, and then you rationalize that, so it becomes radical 2 over 2, and the places where y is equal to radical 2 over 2 is 45 and 135 degrees. All right, let's look at our last example for the day here. All right, so for example 3, same steps apply. We're going to start by moving stuff all onto one side. In that case, those both cancel. And then we need to move this over as well. There's nothing I can really combine it with because the other one has a cosine and a sine, and this one only has a cosine. So we're not actually going to combine it. We're just going to put them next to each other. Oops. There. All right, so we got everything moved over to one side. The next step in the process is to replace the trig functions with some letters. So I'll go ahead and I'll call the cosine x, and I'll call the sine y. Then we're going to go ahead and factor. So what do these have in common? They both have an x in common. All right, the next thing we're going to do is we're going to put the trig functions back now. X is cosine of theta, and y is sine of theta. I'm going to set both of those equal to 0 and solve. So I'm going to set cosine of theta equal to 0. And then I'm going to set 2 sine theta minus radical 2 equal to 0. And we solve both of them. So cosine of theta equals 0 when x equals 0, and that happens in two places. That happens at 90 degrees and also at 270 degrees. And as for this one, we've got to get the sine by itself before we look at our unit circle. And where does sine of theta equal radical 2 over 2? In other words, where are the y values equal to radical 2 over 2? That is at 45 degrees and also at 135 degrees. So this one gives me 4 answers because both factors rendered some answers this time. Okay. And that's the only thing that's really special or different about this one, is that it ended up giving me more answers, which can happen. So let you guys practice one of those, and we'll look at the answer after that. All right, so here's our solutions. For the first one, if you minus this 3 cosine theta on both sides, they go away. And then if you move this whole piece over by adding it over, you end up with our first result there, where the whole thing equals 0. Next, replacing tangent with x and cosine with y, we get this. Step 3 is to factor, so I factor out an x. Step 4 is to replace the x and the y with tangent and cosine again. Step 5 is to solve by setting each of these pieces equal to 0. And if you solve those, for the tangent you get 0 and 180, and for this one over here, after you subtract 1 and divide by radical 2 and rationalize, you would get 135 and 225. And so there's our final answer for that. And so that'll do it for our lesson for today. Hopefully it was helpful, and we'll see you guys in class to practice this stuff. Till then, have a good one.